Hello and welcome to the second covidiosyncrasy video. My aim in these videos is to take something of the panic out of the pandemic. And in this second video, we'll be trying to answer the question, what happens if you just leave it alone? That is, just allow a COVID-19 outbreak to run its course. In the first video, we saw how the handling of the spring 2020 COVID-19 outbreak in the UK was greatly influenced by the results of a model from Imperial College London. This suggested that more than 500,000 would die without any governmental interventions, and that 250,000 would die even with the moderate mitigation measures in place at that time. In both cases, health service intensive care capacity would be overrun many times over. In the first video, we also saw that the exponential growth assumed by the model was never, in fact, evident. A hypothetical exponential trajectory is shown in this graph by the dashed orange line, a constant growth factor, until the hypothetical effects of lockdown begin to show, and the line curves downwards. The actual growth factor, as measured by the ratio of deaths this week to deaths last week, is shown by the blue line. And as you can see, that's in decline from the start. In other words, the growth of the outbreak was always sub-exponential, and that makes a huge difference. It turns out that the UK was by no means exceptional in showing this trend. As far back as April, a researcher called Thomas Meunier published a paper in which he performed a rather more sophisticated version of this analysis on data from the UK, France, Spain, and Italy. Fitting a simple bell curve to the overall trajectory of the UK's pre-lockdown trend in daily deaths enabled him to match the actual date and size of peak daily deaths well. The dashed vertical orange line here is the date of lockdown, and the solid orange line to the right is the approximate date at which lockdown effects should become apparent, some 19 days later. And these are the results for the other countries. This is France. Again, you can see there's a good match there between observation and the green dashed line, which is the pre-lockdown extrapolation. This is Spain, and again, a very good match, showing a correlation between the green dashed line, the pre-lockdown extrapolation, and the blue circles, which are the observations. And finally, Italy. Here, the observed peak death rate somewhat exceeds the pre-lockdown extrapolation, but in general, as you can see from all four countries, the match is pretty good. And here are all four alongside each other for comparison. The other thing to notice, which all four charts have in common, is that peak deaths follow very soon after the dates around which lockdown should become effective. Now, I can't stress this enough. This is pure coincidence. We shouldn't be duped into thinking, therefore, that lockdown somehow caused the peak in deaths at these points. Why not? Well, as we saw last time, it's all to do with the growth rate. The growth rate actually varies with time, and this is calculated simply by taking the logarithm of the ratios of the deaths on consecutive days. Now, if we had exponential growth happening, then the dashed green line in these charts should be horizontal. You can't see the dashed green line too clearly in the bottom right-hand corner chart, which corresponds to the UK, because it pretty much overlays the grey line. But in any event, as you can see consistently, right from the word go, that line is going diagonally downwards, which means that the growth factor is declining steeply from the word go. It's not waiting for lockdown to take effect before it starts doing that. And this pretty much replicates what we found in the first video by simply looking at the weekly death data in the UK. Again, extrapolating onwards from around the date when lockdown should become effective, takes us through to the week ending the 17th of April, when in fact deaths did peak. So Meunier does a pretty good job of reproducing the first part of the daily death curve on the basis of pre-lockdown trends. However, his method is much less successful at reproducing what happens after the peaks. Because like the Imperial College model, he's basically assuming a symmetrical bell-shaped curve. Whereas in fact, the actual curves turn out to look rather different, if very similar to each other. And I've got here some actual curves, typical data for the UK, Spain, France, and Italy. The descent from the peak, as you can see in each case, is much more gradual than the very rapid ascent on the left-hand side. So what's going on here? Well, this is where Stanford University's Professor Michael Levitt, the Nobel Prize winning structural biologist and renowned numbers guy, comes in. Levitt had taken a keen interest in the pandemic from its earliest days in China. He was worried by the prospect of exponential growth in numbers, so began to follow the daily death toll closely. What he discovered was that amid the usual noise of the daily data, the growth rate actually started to decline very, very early on. And drawing on his mathematical knowledge, he embarked on an extensive analysis of the data as it emerged, first in China, then in Italy, and elsewhere. And this led to his concluding that in country after country, COVID-19 outbreaks were well captured by the behavior of something called the Gompertz function. Now, this is widely used in biology to describe the growth of plants and animals, as well as the number or volume of bacteria and cancer cells. In this illustrative graph, the red curve is equivalent to daily deaths, and the blue curve is equivalent to cumulative deaths. So the blue curve represents the ongoing summation of the red curve over time, or at least it would do if they were both plotted to the same scale. Now, mathematically speaking, what accounts for the shape of the Gompertz curves is that there's not one, but two exponential functions in there, represented as usual by the letter E, Euler's number, in this equation. And these functions are pulling in opposite directions. That's the point. One of them wants the numbers to grow exponentially, just as in the Imperial College model. But the other is wanting to slow down that growth by exponentially shrinking the growth factor. The net result is the odd, lopsided daily growth curve that's so typical of COVID-19 outbreaks, at least in relatively high latitude, temperate climates. Well, that's nice maths, you might be thinking, but what physically, what biologically is actually going on here? What's responsible for shrinking the growth factor in this way? We've seen that lockdown has little or nothing to do with it. Well, this is a topic in itself, and I'll come back to this in a later video. But what we can conclude for now is that COVID-19 outbreaks are naturally self-limiting at a level which is much lower than that forecast by simple epidemiological models that assume a homogeneous and wholly susceptible population. And at temperate latitudes, this leads to the familiar Gompertz curves, as illustrated here. We should notice, though, that the curves look very different at lower latitudes. Now, here's a composite graph showing COVID-19 related deaths per million for various Latin American countries, including Mexico. Now, obviously, something rather odd has happened with Peru's statistics in late July, but the common trend is clear. Rather than the steep increase in cases, followed by a long, slow decline, which we saw in Europe, instead we see much longer, flatter curves. Brazil, for example, has been pretty steady at around 5 deaths per million ever since early June. And we can, of course, question the quality of the data in some places, but the common trend speaks for itself. Interestingly, the contrast between high and low latitudes was noted long ago by someone called Edgar Hope Simpson in his study of seasonal influenza. Now, here's a chart taken from his book. The bottom panel shows a very passable Gompertz curve at high latitudes in the southern winter hemisphere. Now, this is replicated in the top panel for the northern hemisphere, but it's harder to see there because it's been cut down the middle. At lower latitudes, notice that the peaks are less high and are distributed more evenly throughout the year. The parallels with the progression of COVID-19 are unmistakable. And what we're seeing with the pandemic is just the natural progression of this kind of respiratory disease. And Ivor Cummins has a useful short video on this, and there's a link to it on the web page. Incidentally, going back for a moment to some of those curves from Latin America, it's worth noting that Argentina, Bolivia, Colombia, and Peru implemented severe lockdowns as long ago as March, and yet the pandemic has continued its inexorable, if gradual, spread. It looks like the inherent seasonality of influenza-like illnesses plays out regardless of how much self-flagellation people impose upon themselves. Once again, we see that over the medium term, lockdown doesn't save a single life, but only serves to intensify and extend the misery. In our next video, we'll be putting lockdown under the microscope again, specifically looking once more at the UK and Europe and asking whether lockdown was too little or too late.